It. Okay, let's begin. The question number 23. Find all points of discontinuity of f where fx is equal to sin x by x if x is less than 0, x plus 1 if x is greater than equal to 0. And question number 24. Determine if f defined by this is a continuous function. Whether this function is continuous or not, we will check. Actually, here we have to find the points of discontinuity, and here we have to check the continuity. Right? Here functions are this already we got, isn't it? So let us begin. Given fx is equal to the question itself. Now here this function is defined for all real numbers because you see x less than 0 means all negative numbers. Here suppose this is your real number line, and then this part x less than 0, all negative real numbers, is that minus infinity to 0. So every negative real numbers are included here, and then next you see x greater than equal to 0 means 0 is included and all positive real numbers are included. Hence this function is defined for all real numbers. So to check the discontinuity, we will check first continuity, where the function is continuous or where not. Okay, so for that, case 1, for the negative real numbers we will check. So let x is equal to c less than 0 be an arbitrary real number. Any real number is we are considering, so that we can check the continuity there. Okay, at x is equal to c, the value of the function is, what is the definition of that function in that interval? That is fx is equal to sin x by x. So value is c is equal to sin c by c, isn't it? Then next let us find the limiting value of the function. Okay, that is limit x tends to c fx. Okay, in fx the function is defined as sin x by x. Here we will put x is equal to c because c is a negative real number, isn't it? Now putting x is equal to c, we get this limiting value sin c by c, which is exactly same as the value of the function. So this function is continuous for all x less than 0 because of this, both of values are equal. Okay, this is a simple concept, you understood, I think. Now case 2, at x is equal to 0. Left hand limit x tends to 0 negative fx. Why we are going to find left hand limit? Because on left side of 0 our definition and on right side of 0 definition are two different function definitions. That is why we will have to find here left hand limit and right hand limit. Got it? So now for left neighborhood of 0, fx is equal to sin x by x. Now limiting value of this function is 1, isn't it? This is, and then we will move to find the right hand limit. We are going to find the value of limiting value of fx when x approaches to 0 from right side, isn't it? And for that fx is defined as x plus 1. So here 0 plus 1 will give us 1. That means left hand limit is equal to right hand limit. That much we got now. Now let us see at x is equal to 0. Value of the function at x is equal to 0, fx is equal to f0, 0 plus 1, which is 1. And all these three values are equal. So f is continuous function at x is equal to 0. Fine. Now for all positive real numbers, let us consider an arbitrary c. Arbitrary real number we consider for intervals, isn't it? That is the process. Now limit x tends to c fx. Fx is here x plus 1. Here in place of x we will put c. So we will get c plus 1, right? Now see, at x is equal to c, the value of the function is also same, fc c plus 1, isn't it? So they are same, means for all positive real numbers our function is continuous, right? So hence we didn't get any point of where function is discontinuous, isn't it? So there is no point of discontinuity of the function, everywhere continuous. That means fine. This is all about our question number 23. Now let us move question number 24. Here our fx is defined as x square sine of 1 by x when x is not equal to 0, and 0 if x is equal to 0. So again you see the function is defined for all real numbers. When x is not equal to 0 means x may be positive or may be negative, right? So this part, minus infinity to 0, x less than 0 for all negative real numbers here. That means the function is defined for all negative real numbers. And you see for all positive real numbers the function is defined, and at x is equal to 0. So this function is defined for all real numbers, negative, 0 and for positive. Okay? Positive and negative real numbers, our function is defined as this, x square sine of 1 by x, and at exactly 0 your fx is equal to 0. This much is to be used, isn't it? So here the given function is defined for all real numbers. This much is our given information. So let us consider an arbitrary real number for checking continuity. We will see this is not equal to 0 means for both positive and negative real numbers we can check the continuity of this function, isn't it? So value of this function is fc is equal to c square sine of 1 by c. Okay, this is value of the function. Now limit extends to c of x. So fx is x square sine of 1 by x, because c is not equal to 0 means either positive or negative. For either positive or negative real numbers our function is fx is defined as this way. So we are using x square sine of 1 by x, isn't it? Right? Next, limit is distributed to x square and sine of 1 by x, and then we'll get c square sine of 1 by c, which is exactly same with the value of the function at c. That means for positive or real numbers the function fx is continuous. This can be concluded from here, and hence limit x tends to c fx equal to fc, f is continuous for all x not equal to 0. Now we are left only to check with x is equal to 0. If x is equal to 0, then f0 is equal to 0. Why f0 is equal to 0? That is given. Now when x tends to 0 negative of fx, then we have to use x square sine of 1 by x. In that case, what will be the limiting value? Let's see. Since sine of 1 by x is a value, finite value between minus 1 and 1, isn't it? X not equal to 0, because sine 1 by x is there and x is in the denominator. Also x not 0 because we are going to find the limiting value, is not it? So here in place of x we can put 0 square we will get, and then sine of 1 by x for this limit a finite quantity between minus 1 and 1, and product of these two quantities is 0. So left hand limit is equal to 0. Right hand limit the same way we will proceed, 0 square, exactly same way, 0 square a finite quantity between minus 1 and 1, because sine 1 by x is a finite quantity between minus 1 and 1, so which gives us right hand limit 0. We get left hand limit, right hand limit, value of the function same, which is 0. So f is continuous at x is equal to 0, right? the function is continuous for all real numbers. So this function has also no point of discontinuity in the set of real numbers. Got it? Okay. Thank you.